A bonding bushing is generally not required at a subpanel when that subpanel is connected to the service panel with an equipment grounding conductor known as an EGC, and the EGC is properly separated from the grounded conductor within the subpanel itself. The primary reason for this lies in the fundamental function of the EGC. The EGC presence establishes a dedicated, low-impedance path for fault current to return to the source, typically the service panel. This low-impedance path ensures that, in the event of a ground fault, where a live conductor comes into contact with the grounded metal part, a substantial amount of fault current will flow. This high fault current will quickly trip the overcurrent protective device, such as a circuit breaker or fuse, effectively disconnecting the circuit and preventing the metal parts from becoming dangerously energized. Without a properly functioning EGC, a ground fault could result in a metal enclosure of the subpanel remaining energized at a potentially lethal voltage, posing a significant shock hazard. However, there exist exceptions to the general rule regarding bonding bushings. These exceptions are typically dictated by specific environmental conditions or installation methods. Firstly, if the subpanel is situated in a wet or corrosive environment, a bonding bushing might be mandated. The increased conductivity and potential for corrosion in such environments can compromise the integrity of the electrical connections and increase the risk of ground faults. A bonding bushing helps to ensure a more reliable and robust connection to ground, mitigating these risks. Secondly, if the subpanel is connected to the service panel using multiple EGC, a bonding bushing may also be required. Multiple EGC can create parallel paths for fault current. While this might seem beneficial, it can also lead to circulating currents and increased impedance if the parallel paths are not properly bonded together. A bonding bushing helps to equalize the potential between the multiple EGC, preventing circulating currents and ensuring that the fault current is effectively routed back to the source. Thirdly, the specific requirements outlined in the National Electrical Code, known as the NEC, must always be adhered to. The NEC provides detailed guidelines and regulations for electrical installations, and it is the final authority on whether bonding bushing is required in a given situation. It is crucial to consult the latest edition of the NEC and any applicable local amendments to ensure compliance. To determine the necessity of a bonding bushing, several factors are considered. Firstly, the type and size of the conduit connecting the service panel to the subpanel are important. Metal conduit, such as EMT, electrical metallic tubing, can serve as an equipment grounding conductor if it is properly installed and connected. However, non-metallic conduit requires a separate EGC to be run alongside the conductors. Secondly, the presence of concentric knockouts on the subpanel enclosure is relevant. Concentric knockouts are partially removed metal rings that are designed to be easily removed to accommodate different sizes of conduit. However, they can create a high impedance path for fault current if they are not properly bonded. A bonding bushing can help to bridge the gap created by the concentric knockouts and provide a low impedance path for fault current. Thirdly, the voltage and amperage of the circuit feeding the subpanel are also taken into account. Higher voltage and amperage circuits generally require more robust grounding systems to handle the increased potential for fault current. Fourthly, the local electrical codes and regulations are paramount. Local codes may have specific requirements for bonding and grounding that go beyond the NEC. It is essential to consult with the local electrical inspector or authority having jurisdiction, known as the AHA, to ensure compliance. The role of the electrical inspector is to verify that the electrical installation meets all applicable codes and regulations. While inspectors generally adhere to the NEC, they also have the authority to interpret the code and make decisions based on their professional judgment in local conditions. If an inspector requires a bonding bushing in a situation where it is not explicitly required by the NEC, it is generally advisable to comply with the inspector's request. Arguing with an inspector can be unproductive and may delay the project. However, it is also important to understand the reasoning behind the inspector's requirement. If you are unsure why the inspector is requiring a bonding bushing, you can politely ask for clarification. The inspector should be able to explain the specific code section or local regulation that supports their decision. If you disagree with the inspector's interpretation of the code, you can appeal their decision to a higher authority, such as the local electrical board or the state electrical inspector. However, this process can be time-consuming and may not be successful. In most cases, it is more efficient and cost-effective to simply comply with the inspector's request. Ultimately, the goal of all electrical installations is to ensure safety and prevent electrical hazards. Bonding and grounding are critical components of a safe electrical system. While bonding bushings may not always be required, they can provide an extra layer of protection and help to ensure that the electrical system is properly grounded. Firstly, determine if the subpanel is located in a wet or corrosive environment. If it is, a bonding bushing may be required, regardless of other factors. Secondly, check the type and size of the conduit connecting the service panel to the subpanel. If metal conduit is used, ensure that it is properly installed and connected. If non-metallic conduit is used, ensure that a separate EGC is run alongside the conductors. Thirdly, inspect the subpanel enclosure for concentric knockouts. If concentric knockouts are present, a bonding bushing may be required to bridge the gap and provide a low impedance path for fault current. Fourthly, consult the latest edition of the NEC and any applicable local amendments. The NEC provides detailed guidelines and regulations for bonding and grounding. Fifthly, contact the local electrical inspector or AHA to ensure compliance with local codes and regulations. If the inspector requires a bonding bushing, comply with their request even if it is not explicitly required by the NEC. In summary, a bonding bushing is generally not required at a subpanel when the subpanel is connected to the service panel with an EGC and the EGC is separated from the grounded conductor in the subpanel unless specific environmental conditions, installation methods, or local codes dictate otherwise.